we have come to a new topic of under matrix, which is Hermitian matrix. So when matrix elements were all real, we had to check the matrix for symmetric or skew symmetric matrix, right? But what if the matrix elements are not all real? There are imaginary or complex elements as well. Then we need to check for Hermitian or anti-Hermitian matrix. So what is a Hermitian matrix? It is basically a square matrix which, if satisfies this condition, that is A dagger is equals to A, then it is said to be Hermitian matrix. That is a matrix with imaginary numbers as its elements satisfying the condition A dagger is equal to A is said to be Hermitian matrix. Now, what is dagger? Dagger is nothing but the transpose of its complex conjugate, right? So consider A to be 0, 2 iota, minus 2 iota, 2 iota and 0. Alright. So A dagger changes to be, what will be the complex conjugate of this matrix? 0 will remain 0, minus 2 iota will become plus 2 iota, plus 2 iota will become minus 2 iota and 0 with a transpose. So now A dagger becomes 0, 2 iota, 2 minus 2 iota and 0, which is nothing but A, right? We started with this as the A. Right, so this is exactly identical to A dagger, which is this. Alright, so what we could see is A dagger is becoming equal to A, and hence we can say that A is Hermitian. Alright, now coming to the next topic, which is anti-Hermitian or skew Hermitian. Alright, so a matrix is said to be anti-Hermitian if it satisfies the following condition. And what is the condition? A dagger is equals to minus A. Alright. So for this matrix, the diagonal elements should either be 0 or purely imaginary numbers. Alright. So we'll see another example of this. Consider the following matrix where A is equals to 2 iota, minus iota, iota and again 2 iota. Alright. So what will be A dagger? A dagger will be transpose of its complex conjugate, and what will be the complex conjugate? Replace all the iota by minus iota. Alright, so A dagger changes to be minus 2 iota, iota, minus iota, minus 2 iota. Alright, so A dagger so what we can see is A dagger coming out to be A dagger is not coming out to be is A dagger coming out to be minus A? No, A dagger is not coming out to be minus A. So what we can say, that this is not an anti-Hermitian matrix. Alright. So what is an anti-Hermitian matrix? Let us look into another example. Example number 2. Consider 0, 2 iota, 2 iota, 0. Alright. Find, this is nothing but A. Find out A transpose. What will be A transpose? 0, minus 2 iota, minus 2 iota and 0, and transpose of that, right? Because we have found the complex conjugate and we need to do the transpose of the complex conjugate in order to find the dagger of A. So complex conjugate is nothing but replace every iota with minus iota. So transpose of this will be 0, minus 2 iota, minus 2 iota, 0, right? Now look, A dagger is coming out to be nothing but minus A, isn't it? So here we can say that A is Hermitian. Alright. Now we will talk about the next variety of matrix, which is orthogonal matrix. A square matrix is said to be orthogonal if and only if it satisfies the following condition. What is the condition? A transpose A is equals to A transpose is equals to identity matrix. Only then will A be called a orthogonal matrix. Alright. Now let us look into this equation a little more deeply. So what we have written that A transpose is equals to I. Let us multiply A inverse from the left hand side of this equation. So A inverse gets multiplied on both left hand side and right hand side of this equation. A inverse makes I into A transpose is equals to A inverse into I. So by comparing both the sides, what we can say is A transpose is equals to A inverse, right? So transpose of an orthogonal matrix is equal to its inverse. This is what we can infer for an orthogonal matrix, that its transpose becomes equal to its inverse. Alright. Now comes another important division of matrix, which is unitary matrix. Well, so what is unitary matrix? For real matrix, we have checked for if it is a symmetric matrix or an antisymmetric matrix or an orthogonal matrix. But what if we have an imaginary or complex matrix? For imaginary matrix or for complex matrix, that is a matrix whose elements are complex numbers, that is they contain iotas or imaginary numbers, then we check for Hermitian properties or check for its anti-Hermitian properties or unitary properties. So for real matrix, we check for symmetric, antisymmetric and orthogonal properties. For imaginary or complex matrix, we check for Hermitian, anti-Hermitian and unitary matrix, like unitary properties. So what is an unitary matrix? A square matrix is said to be unitary if it satisfies the following condition. And what is the condition? A dagger is equal to A dagger A is equal to I, which is I means identity matrix. So let us now simplify this. A into A dagger is equals to I, right? So A inverse A dagger is equals to A inverse I. Now A inverse A makes I, right? Multiplied with A dagger is equals to A inverse into I. Now comparing both sides, what we can say is that A dagger is equals to A inverse, right? So this is the property of an unitary matrix, that its dagger becomes equal to its inverse. Alright, now let us look into an example. So consider an example, consider a matrix A is equals to 0, 2 iota, minus 2 iota, 2 iota and 0. Alright. So what will be A dagger? A dagger is nothing but transpose of its complex conjugate. So replace all the iotas by minus iota and find its transpose. Alright. So this becomes equals to 0, 2 iota, minus 2 iota and 0, which becomes equal to A dagger. So A dagger A becomes equal to 0, minus 2 iota, 2 iota, 0. And what is A? 0, minus 2 iota, 2 iota, 0. Alright. So multiplying these becomes this is equal to 0 into 0 plus 4. This becomes 0. Again this becomes 0 and this becomes 4, which is 4i. So this is not becoming equal to I. So this is not a unitary matrix. Alright. But then, so A is not a unitary matrix. But what if we take A to be 0, minus iota, iota, 0? Then A dagger will change to 0 iota, minus iota, 0 transpose. So A dagger changes to 0, minus iota, iota, 0. Alright. And A dagger A changes to 0, minus iota, iota, 0, 0, minus iota, iota, 0, which is equals to 1, 0, 0 and 1, right, which is equals to identity. So here we can say that A is an unitary matrix, right? So that's all for the properties and types of matrix. We'll continue with matrix in the next video as well, but then we'll talk about some different topics like eigenvalues, vectors. All right.